All right, today we're going to go on a bit of a treasure hunt. We're digging through Python's huge ecosystem to uncover some of those hidden gems. The things that you might not use every day, but that really show off the genius of the language. So let's get into it. So let me ask you this. What really makes Python a world-class language? I mean, is it just the clean syntax? Or maybe the huge community that's always there to help? Well, yeah, those things are definitely a big part of it, but Python's real secret weapon is something much, much deeper. It's the whole ecosystem. It's that famous batteries included philosophy, right? Python is just packed with these powerful tools, ready to go right out of the box. So today, we're going to take a tour from the inside out. We're starting with one tiny, elegant algorithm, and we're going to zoom all the way out to the global infrastructure that keeps the whole community safe. Okay, let's start at the very core of Python. We're going to look at a problem that I guarantee every single programmer has run into. How do you efficiently find the most important stuff in a giant pile of data? Just imagine you have a billion with a B user scores and you only need to find the top 100. Now, you could sort the entire list, but that would be incredibly slow. Just a total waste of time and energy. There's got to be a better way. And of course there is. Python's heap queue module uses this really clever data structure called a heap. And the secret sauce to its speed is this one simple rule called the heap invariant. The easiest way to think about it is like a company org chart. In a min heap, every manager or parent is always smaller than their direct reports or their children. And this one little rule makes all the difference. Because of that one rule, the smallest item in a min heap is always just sitting right there at the top, in the first position. You don't have to search for it at all. And for a max heap, it's the same deal, but for the biggest item. This gives you instant access to what you're looking for, which is just incredibly useful for so many things. So how does it stay so fast? Well, think of it like a tournament. To get the next smallest item, you just take the winner from the top. Then you grab the very last element, stick it in that top spot, and let it percolate down. It just keeps swapping places with its smaller children until that main rule is restored. This is what we call a logarithmic time operation. And in plain English, that means if your data doubles from 1 million to 2 million items, it only adds one single extra step. It's just unbelievably efficient. Okay, so we've seen how Python handles a core algorithm. Now, let's zoom out a little bit to the next level, the essential utilities that developers are using every single day. These are the real workhorses of the standard library. I mean, take the random module. It's a perfect example of batteries included. It's for so much more than just getting a random number. Need to pick a single raffle winner from a list? Boom, Choice does it. Simulating rolling a die 10 times? Choices has you covered. Shuffling a deck of cards? Shuffle does it in a flash. Each one of these functions solves a really common problem, so you don't have to write that code yourself over and over again. And the logging module is another brilliant piece of design. Instead of just throwing print statements all over your code, you can direct your messages wherever you want. And here's the best part. Your application code doesn't have to change at all. You can switch from logging to the console, to a file, or even send a critical error alert through email just by swapping out a handler. Now that is flexible design. Okay, let's move up another level of abstraction. This is where Python truly shines, bundling solutions to these really complex, domain-specific problems. Things like email archives, even DNA sequences, into simple, powerful modules. Email is the perfect example here. Over the years, people have come up with dozens of different, totally incompatible formats for storing mail. So how on earth could you write one script that's supposed to work with all of them? I mean, you've got old school formats like Mbox, which crams every single email into one gigantic, fragile file. Then you've got modern ones like Maildir, which neatly stores each email as its own file in a directory. These are completely different philosophies for storing data, and trying to handle both is a real nightmare. But here's the thing, with Python's Mailbox module, you don't have to worry about any of that complexity. It gives you this single, consistent interface that just works like a Python dictionary, no matter what the underlying format is. You can loop through messages, add new ones, delete old ones, all with the exact same simple code. It just works. All right, now for our final and biggest jump, security. We are zooming all the way out to the macro level to talk about how Python is working to secure its entire global package ecosystem for every single developer out there. Think about it. When you type pip install, you are downloading and running code straight from the internet. how do you actually know that you're getting the real deal from the author and not some malicious version that an attacker managed to sneak in? Well, the answer is a new standard called attestations. The easiest way to think of an attestation is like a digital notary seal for software. It's a cryptographically verifiable proof that a package was published by who it says it was and that it has not been touched since. So, how does this digital seal actually work? It's pretty straightforward, really. It's got two parts. The envelope holds the core claim, like I, the creator, published this exact file, along with a digital signature. Then you've got the verification material, which contains everything you need to prove that signature is valid and trustworthy.
So when you install a package that has an attestation, pip automatically runs this really rigorous check. It's like a security guard with a checklist. It verifies the certificate, it checks that the file's contents are an exact match, and it validates that digital signature. If everything lines up, you're good to go.
And the result of all that? You get mathematical certainty that the package you're about to install is the real deal. This is a massive step forward for the security of the entire open source world. So there you have it. In just a couple of minutes, we've gone from the beautiful logic of a single algorithm all the way out to a cryptographic shield that protects millions of developers across the globe. And this is what makes Python so special. It isn't just one single feature. It's the thoughtful, layered, practical engineering that you find at every single level of the ecosystem. And what we've seen today? That's barely scratching the surface. The Python standard library has over 200 modules. Each one of them is a powerful tool just waiting to be used, often solving a problem you didn't even know you had yet. So, from the very core data structures all the way up to global security, Python gives you these powerful, thoughtfully engineered tools. The only question left is, with this huge treasure chest right at your fingertips, what hidden gem are you going to uncover next?